Welcome to the RevHD Wheel End training video. This course is designed to instruct participants on how to properly diagnose and correct various wheel end issues, as well as effectively install all wheel end components so that they perform safer and more efficiently. This training course is designed to show you how to make any manufacturer's seal last longer. In addition, we will cover bearing adjustment procedures for both manually adjusted and preset hubs. This is the most comprehensive wheel end training course available, and it's free, whether you are using RevHD components or other manufactured products. RevHD strongly believes it is important to teach the procedures that will create a safer environment both on the road and in the shop. If you're watching this video on the RevHD website, there is a link you can follow after this video that will take you to a short quiz. A passing grade of 85 or better on this quiz will earn the participant a certificate for this wheel end training course. Additionally, for RevHD wheel seal customers, passing this quiz provides a wheel seal warranty that includes the brakes. So let's begin. There are 5 leading causes of wheel end failure. 1. Improper installation. 2. Incorrect bearing adjustment. 3. Contamination. 4. Worn or damaged components, such as a bad shoulder or hub bore, or reinstalling damaged bearings or locking nuts. 5. Clogged vent hole, either on the hubcap or the drive vent. This training course will give you remedies for all 5 of these failure modes and help you diagnose problems before they occur to ensure that the wheel ends you put together perform better, safer, and last longer. Chapter 1. Inspection and Teardown. If you know the seal has leaked prematurely, or you have other concerns associated with the wheel end, you may want to take a few extra steps as you take the wheel end apart to properly diagnose what went wrong. Note, a leaky seal is one in which the oil is beginning to drip down from the seal. If the seal is simply moist or damp, it does not necessarily mean you have a faulty seal. A little bit of moisture or dampness on the seal is okay. Begin by examining the hubcap. If the wheel end was using oil, the first thing you'll want to do is check the add and full lines on the window of the hubcap. Too little oil can indicate a leaky seal or a leak around the hubcap gasket, flange, window, or plug. Too much oil can cause the seal to leak or cause oil to be pushed out of the sides of the hubcap or the hubcap plug. Next, examine the hubcap plug itself. Check the vent hole located in the center of the plug. If the vent hole is clogged, pressure building up in the hub can blow out the seal, causing it to leak. Use a paper clip or other small instrument to unclog this vent hole. Note, it is important not to use anything that will make the hole larger, such as a screwdriver or pocket knife. The RevHD hubcap comes with a clog-free plug which utilizes a one-way check valve that allows pressure out but prevents water and other contamination from getting in. Another thing to notice pertaining to the hubcap plug is discoloration. If the color of the plug has faded to a white or yellow, or the rubber has become soft or brittle, this could indicate heat damage or dry rotting. It is recommended that you replace this plug with another plug made by the same hubcap manufacturer. Some other things to look for on the hubcap is leakage around the window. If an aftermarket window kit was installed improperly, you could have leakage around the edge of the window or gasket. If the bolts have been over-tightened or not installed in a crisscross pattern, a leak may occur. While most hubcap manufacturers offer window kits, most wheel end experts will recommend that you simply replace the entire hubcap versus attempting to reinstall a separate window kit. The difference in cost is minimal, particularly when you factor labor into the equation. Lastly, check for cracks around the flange of the hubcap. Again, if the bolts were over-tightened or not installed in a crisscross pattern, cracking can occur around the flange itself. To help with these problems, RevHD has designed hubcaps with one of the thickest flanges on the market. RevHD hubcaps also have reinforced spokes across the lens to prevent breaking or cracking. In addition, RevHD are the only hubcaps to come with a heat check sensor. Included in every box is a heat check bolt, which will extend if the temperature of the hub reaches 250 degrees or hotter. At 250 degrees Fahrenheit, bearings will begin to show signs of damage. At 350 degrees, many lubricants can ignite. This sensor is designed to alert you before a catastrophe occurs. Remember to always use a new gasket when installing or reinstalling a hubcap. Never use silicone or other sealant on a gasket. The gasket should always be installed dry. After examining and removing the hubcap, next look at the locking nuts. There are single nut systems as well as traditional double nut systems commonly used today. Examine these nuts carefully. If it is a single nut with a clip or tabs, examine those items to make sure they are locked in place correctly. Here we see an example of a clip that was inserted incorrectly. The top of the clip is on the outside of the nut. It is not engaged with the teeth of the nut. This could potentially result in a wheel off. Other common single nuts utilize tabs on either side of the nut to lock the nut in place. Inspect these tabs to make sure they are fully engaged and locked.
Well, this is another common nut setup that you'll see on a lot of trucks and trailers out there is what's called the axi-lock. The axi-lock, you have to have a really nice socket that goes over these clips and it pushes these clips in to take the tangs out of the clip to disengage them so you can do your torque procedure. What happens is on this nut a lot of times is if your socket's not perfect, that the little clips will break off inside of there. So unless you use a brand new socket, just be really aware that if you break one of those little tabs off, that you really have to make sure that you replace these nuts. On this particular example, both the tabs are broken off on both sides, and there's no way that this nut will ever engage. And if you try to use that nut, that you're going to have a set of tires that will probably come off. And the most common setup that you'll see on a truck or trailer is the double nut setup, where you have an inner nut, an outer nut, and the washers and the bend up tabs. Some of the things to look for on these nuts is if people have used chisels, and this one they'd use a chisel to not only put it on but also to take it off. This one had been put on with an impact gun where the socket rounded off the edge of the nut. This one had used a chisel to not only to put it on but also to take it off. Now that's what people use. This is the outer nut, so that's obviously what somebody used as their torque procedure on that nut, was to use that instead of a torque wrench to lock it down. Then they bend the tabs over on here. But what happens if you don't have that 1 to 5 thousandths just right, if you look at the threads on the inside of these two nuts right here, those threads are completely stripped out and they're bare. There's no threads left inside of these nuts. So if you ever see damage on nuts like these, make sure that we replace those nuts and we do not reuse those.
RevHD always recommends using a dial indicator after performing a bearing adjustment. However, if there is an issue surrounding the wheel end you are tearing down, you may also want to use a dial indicator before taking the locking nut off to determine whether the previous bearing adjustment may have caused the issue. TMC recommends an end play of 1 to 5 thousandths on a manually adjusted hub and 0 end play on a hub containing a spacer. On this particular wheel end, we see that the needle does not move when rocking back and forth on the hub. This indicates a bearing adjustment that is too tight. A bearing adjustment that is too tight can cause premature seal failure and/or bearing failure. Over time, it can cause spindle damage and poor fuel economy.
Your typical wheel end should be within 1 to 5 thousandths of dial indication. That's your proper end play in and out on that wheel end. So you want to give it a little bit of a slight rotation to bottom out the needle.
If the needle on the dial indicator was to move more than 5 thousandths, this would indicate a bearing adjustment that was too loose. This also can cause premature seal and bearing failure, spindle wear, and tire wear. If this were a preset hub utilizing a spacer, which we will talk more about later, then zero in-play is recommended. Many technicians tend to overcompensate on the bearing adjustment and perform bearing adjustments that are too tight. This course will go over proper bearing adjustment in greater detail in a few moments. After removing the locking nuts and undocking the hub, make a quick examination of the seal itself before prying it out of the hub bore. In this case, we can see that the spring on the seal has slipped out. You will also want to check the face of the seal for dents that could indicate it was damaged during installation or when docking the hub. Also check the ID and OD of the seal for cuts or gashes, possibly caused by burrs or the spindle threads when installing the seal and docking the hub. If you are taking this wheel end apart because of a premature seal leak or other wheel end failure, it might be a good idea to mic both of the bearing journals on the spindle, particularly if this is a wheel end that has continued to give you problems in the past. Mic the bearing journals at 3 and 9 o'clock, then take another measurement at 12 and 6 o'clock. Most spindle or shoulder wear will be evidenced on the bottom of the spindle near the shoulder. If the difference between the two measurements is greater than 6 thousandths, it is recommended that you replace the axle or spindle itself. No wheel seal will be able to fully prevent leaks with this degree of wear on the spindle. Cleanliness is always critical in every aspect of the wheel end. Use a wire brush and emery cloth to clean the spindle threads, and the spindle shoulder. Note, some seals have a thinner inner diameter than other seals. If the seal you have removed has a thinner inner diameter, then dirt, rust, and other contamination may have built up towards the back of the shoulder. The RevHD seal has a wider inner diameter than other seals on the market. This provides more sealing surface area on the spindle shoulder. However, if the shoulder is not cleaned far enough back, the contamination can push the seal or ride underneath the lip of the seal and cause premature seal failure. When installing a RevHD seal or any other seal that offers the benefit of a wider inner diameter, always make sure you clean the entire surface of the spindle shoulder.
If you don't remove that buildup all the way back as far as the inner diameter of that seal is, when that seal starts to go over the spindle shoulder when you install it, it'll cause a lot of internal pressure on that seal, on those very inside rings that you see inside that seal. It can cause the inside of that seal to crimp in, and it'll cause a leaker because of the inner pressure and contamination of pushing in on the inner lip of that seal. So let's just make sure that we're cleaning it up.
To remove the previous wheel seal, use a pry bar or other instrument to get between the seal and the outer bearing. Then pry the seal out of the hub bore. Some seals will be easier to remove than others. Rubber-coated seals are typically easier to remove than metal seals. There are tools on the market that can also aid in removing the seal if you find that the pry bar is not sufficient. However, you should never use the bearing as a punch to knock the seal out, unless your intentions are to replace the bearing and the race. Once the bearing has been struck in this manner to remove the seal, it is highly recommended that you do not reuse the bearing or race. If you have loosened the outer cage of the bearing by striking it, you could possibly have a bearing failure down the road.
When you look at the cage, you want to make sure that the cage isn't dented in there, or it's been dented in two different places. You want to check your rollers and make sure your rollers aren't pitted. They don't show any discoloration where they turn red, black, purple, where they've shown it's gotten extremely hot.
Whenever you replace the bearing, you should also replace the race. Clean the hub thoroughly. Use an emery cloth around the hub bore where the outside diameter of the seal will ride. Use this same emery cloth around the spindle shoulder. This is a great tip. Doing this will help make the seal last longer. Also check the metal chamfer around the outer edge. These chamfers tend to have burrs, which, if not filed down, can nick the seal during installation, causing premature seal failure. Chapter 2. Reassembly. Once all the components have been disassembled, inspected, and cleaned thoroughly, it is time now to reinstall the wheel end. Begin by lubing the inner bearing with the same lubricant you are using in the hub. Note that if you are using semi-fluid grease or hard-packed grease, you will need to pack the bearings with the same grease. Have you ever installed a seal only to realize you forgot to insert the inner bearing? Mistakes happen, but if you have to remove the seal for any reason, it is important that you replace the seal with a new one every time. Always make sure you are installing the right seal for the hub you are working with. RevHD seals have a part numbering system that tells you if the seal is designed for a steer, drive, or trailer. We also indicate the type of spindle and list an interchange below the part number. If using a seal other than the RevHD, check that seal manufacturer's interchange to ensure you are using the proper seal for the hub you are working with. All RevHD seals are sealed in a plastic wrapping. If you are using a seal that is not sealed in plastic, take note of any dirt or contamination that may have made its way into the seal while it sat on the shelf or was delivered to your location. Also, examine the seal for any signs of dry rotting. Depending on the temperature and the age of the seal, some seals that have not been sealed in plastic can exhibit signs of dry rotting, which can cause the seal to fail prematurely. RevHD seals are also the only seals that come with a special formula designed to cause the rubber to swell slightly after installation. This allows the rubber to fill any imperfections on the hub bore or the spindle shoulder. This special formula also helps protect the rubber over time and makes the seal easier to install. It is recommended that you place a small amount of this special formula around the hub bore just prior to installing the seal. Then put a small amount around the spindle shoulder prior to docking the hub. When installing a seal other than RevHD, you will need to make sure you have the proper tool to install the seal. Most seal manufacturers design specific tools for each specific part number. Using a tool other than the one designed by that seal manufacturer can damage the seal upon installation and cause premature seal failure. If you do not have the proper seal installation tool for the seal you are installing, or your tool has been dropped or damaged, contact the seal manufacturer for a replacement tool. One of the best selling points of the RevHD seal is that you do not need an installation tool to install it. The RevHD seal is uniquely designed to be installed with any flat, clean instrument. This is because the top plate of the RevHD seal is the tool. The good news is this top plate tool remains with the seal after installation to further protect the seal while you dock the hub, or from the elements and the heat from brakes once the vehicle leaves the shop. Note, if you are using a seal installation tool on the RevHD seal, make sure to flip the plate over so that only the flat side makes contact with the seal. This is very important. Make sure to lube the spindle with the same lube you are using in the hub. Also, go ahead and lube the outer bearing and have it close by to insert after docking and filling the hub with lubricant. Take great care when docking the hub to ensure that the spindle does not hit the face of the seal. If the tires are on, use a wheel dolly and line everything up so that the seal and the bearings go uniformly over the spindle and into position. Note, if you hit a burr or the hub is not wanting to go over the spindle easily, do not struggle or wrestle with the hub to get it into position. This can cock or damage the seal. Instead, allow the bearing adjustment to seat everything for you. The bearing adjustment will seat the seal onto the shoulder far more uniformly than you can do by hand. Another important feature of the RevHD wheel seal is its unique flex design, which can help prevent failures commonly caused by cocked seals. Sometimes seals get crooked during installation or while docking the hub. Other times they can cock because the vehicle goes off-road. The RevHD seal's unique flex design allows the seal to flex in critical situations, protecting you from leaky seals caused by tilting or cocking. Of course, before inserting the outer bearing, make sure that you pump lubricant into the hub. If using oil, fill the hub bore up until the oil is just starting to trickle out. If using semi-fluid grease, you will need to fill the hub halfway. This can sometimes be difficult as the lubricant tends to waterfall out before you get it into the proper fill level. The RevHD seal box comes with a tool on the back that will help with hubs using semi-fluid or synthetic grease. If using hard-pack grease, fill the hub entirely, leaving just enough space for the spindle. Note, having the outer bearing already lubed and ready to install will make things easier after you dock the hub. Chapter 3. Bearing Adjustment. Now you are ready to perform your bearing adjustment. This is, without a doubt, the most critical aspect of assembling the wheel end, not only because an improper bearing adjustment can cause seals and bearings to fail prematurely, but because a bad bearing adjustment can cause a wheel off, a fire, or other major catastrophe. Pay close attention to this part of the course, as we will attempt to go over all the various nut systems that exist today and show you the bearing adjustment procedures that are associated with each of them. We will begin by showing you the proper bearing adjustment procedure for the double nut system on a conventional manually adjusted hub. Then we will show you how to perform a proper bearing adjustment using a single nut like RevHD's RevLock Universal Spindle Nut. For a double nut system on a conventional hub, you will need to follow the TMC RP618 chart and count the threads per inch on your spindle. You will also need to measure the outside diameter of the jam nut to conduct the proper bearing adjustment for the spindle manufacturer you are working with. Begin with a torque of 200 foot-pounds. Rotate the hub a few times and then click the torque wrench again. Next, back the inner nut off until loose. Now go back with 50 foot-pounds. Again, rotate the hub and click again. Your final back off on the inner nut will be either a quarter, a half, a third, or a sixth of a turn, depending on the TMC chart and the thread count of the spindle you are working with. A copy of this chart can be found on the RevHD website. Next, place the washer into position. If the holes do not line up, turn the inner nut looser, not tighter, until they do. Lastly, install the outer jam nut. Once again, refer to TMC's RP618 for the true final torque. It will either be 200 foot-pounds, 300 foot-pounds, or 350 foot-pounds, depending on the size of the nut and the type of washer you are using. Afterwards, check your work with a dial indicator. If adjustments are needed, remove the outer nut, star nut, and washer, and then tighten or loosen the inner nut as required. Then reassemble and retorque the jam nut to the appropriate foot-pounds. If all this sounds complicated, there is an easier way. Introducing the RevLock Universal Spindle Nut, a single nut designed by RevHD in cooperation with Temper Corp and manufactured right here in the USA. This RevLock Universal Spindle Nut works with all systems, including TMC RP618 preset hubs or the Doctor preload tool. The hash marks represent the correct back-off for manually adjusted hubs. The dimples indicate 1/1000ths of end-play adjustment. The reusable retainer ring is removed by squeezing the finger tabs together and then disengaging the center tab from the nut. To install on a manually adjusted hub, thread the RevLock nut onto the spindle until it stops against the outer bearing. Begin by torquing the nut to 200 foot-pounds while spinning the hub in either direction. Next, back the nut off one full turn. Now torque the nut to 100 foot-pounds while spinning the hub in either direction. The final back-off is always one hash mark. This will give you the same back-off as if you had counted the threads per inch and utilized the TMC chart, except we have done all the math for you. We pre-stamp the nut so you don't have to count the threads per inch, measure the spindle or the nut. Some RevLock spindle nuts will have 4 hash marks. Others may have 3, 6, or 8 hash marks, depending on the application. Backing the nut off 1 hash mark will precisely adjust the nut to TMC RP 618 guidelines and leave you with a perfect bearing adjustment every time. Install the retainer ring at an angle, ensuring the center tab locks into the teeth of the nut. Next, squeeze the finger tabs to engage the legs into the nut. Lastly, check to ensure the retaining ring is fully engaged into the nut. If engaged completely, none of the Easy View notches should be visible. For preset hubs containing a spacer between the inner and outer bearings, the procedure is always 1 torque with no backoffs. However, the amount of torque will often differ depending on the manufacturer of the spacer or preset hub. Whether you are using the RevLock nut or another manufacturer's nut, always torque the nut 1 time with no backoff. However, you must torque the nut to the specifications of the spacer assembly you are working on. Many spacers will have a different torque ratio, even if they are made by the same manufacturer. Always check with the manufacturer of the spacer you are working with to get the proper torque spec. They can range from 250 foot-pounds to over 550 foot-pounds, depending on the hub and the spacer type. For instructions on using the RevLock nut with the Dr. Preload tool, visit drpreload.com. All wheel end experts will highly recommend that you use a dial indicator after completing any bearing adjustment to ensure that you have done everything correctly. If so, you should have between 1 and 5 thousandths in play on a conventional hub and 0 in play on a hub containing a spacer. Chapter 4. Lastly, if working on a steer or trailer spindle, it is time to install the hubcap. If installing the old hubcap, use a new gasket and always check the hole on the center of the plug to make sure it is clear and free of debris. Install each bolt in a crisscross pattern following the manufacturer's torque specs. The RevHD Severe Duty Hubcap comes with all new bolts and a gasket. We recommend tightening each bolt between 12 to 14 inch-pounds. Now, if it is an oil hubcap, fill the hubcap between the add and full lines. Note it is important to rotate the wheel several times to make sure that when the oil settles, it remains between the add and the full lines. If using semi-fluid grease, hold the hubcap at an angle and fill the bottom quarter of the hubcap before bolting on. If using hard-packed grease, just a slight coating of grease on the inner walls of the hubcap is required. Chapter 5. Let's recap what we have learned. Remember, there are 5 leading causes of wheel end failure. 1. Improper installation. The top plate of the RevHD seal is the tool and can be installed by any flat, clean object. This same top plate tool continues to protect the seal while docking the hub and after the vehicle leaves the shop. Our unique flex design will also help protect you against cocked seals. 2. Incorrect bearing adjustment. Using the RevLock Universal Spindle nut ensures a proper bearing adjustment every time, no matter the spindle manufacturer or thread count. 3. Contamination. Always make sure every component is cleaned thoroughly, and don't forget to clean the spindle shoulder all the way back. 4. Worn or damaged components. If you have wear or other imperfections on the shoulder or hub bore, RevHD's included tube of Seal Extend will ensure that the seal swells into those areas to prevent leaks. 5. Clogged vent hole, either on the hubcap or the drive vent. The RevHD hubcap comes with a clog-proof vent hole. If using another manufacturer's hubcap, check the vent hole periodically to ensure proper ventilation. Now that you have viewed this training video, you may proceed to the RevHD website at revhd.com to take a short quiz to determine your wheel end knowledge. A passing grade of 85 or better will earn you a certificate of completion, which will be emailed to the address you enter when you begin the quiz. This same certificate earns you a RevHD seal warranty that includes your brakes. Thank you for viewing this video. To find out more about RevHD products and where to buy them, visit revhd.com.